before I get started into introductions, I want to start with a quick story, just to kind of set the table a little bit. So today we're going to talk about Bart and Lisa. So Bart and Lisa are they can be anybody in the software world that's concerned with shipping software. Typically this might be your engineer or platform engineer or just like a startup founder, right? And they've been hard at work making some awesome software, and they've got a prototype. They're ready, let's go, let's ship it, and we want to build and test and deploy that software. So we are going to talk about the stories of Bart and Lisa in that context. All right, so let's start with Bart's story. So on day one, Bart has created an awesome service, and we're going to talk a lot about GitHub Actions today. We use GitHub Actions at Airbyte, but this talk is broadly applicable to many other CI/CD systems, GitLab, Jenkins, etc. So Bart's created a back office service, and he's got a CI for it. And he's got a little bit of YAML he created, and he was able to get up and running really, really quickly. He's got this back office service, it's built, it's tested, it's deployed, awesome, really quick, really awesome. So that's day one. Day 11, so Bart's just been cranking out code. He's doing great, He's got a back office service, he's got a cart service, he's got a config service, he's got an inventory service, he's got a lot of different things going on. And he's got several different YAMLs now. He's got one to build his back office, he needs to talk to the config service, and it's starting to pile up, but it's still manageable. He can manage with these. This is day 101. Bart's got quite a few services now. He has too many things going on. He doesn't really know what to do. Every time that he makes a change, there's just all these different things going on, and he just doesn't feel like he can handle it anymore. So what about Lisa? So Lisa decided to do things a little bit differently. And what Lisa has done is the subject of our talk. All right, so the title of our talk is CI/CD Beyond YAML, or How I Learned to Stop Worrying About Holding All These YAMLs and Scale. So a little bit about myself. I am a senior software engineer. I work on infrastructure at Airbyte. And for those of you who don't know what Airbyte is, it is an ELT platform. And it is concerned with helping people move data from different disparate sources such as Stripe, Facebook, Google Ads, Snap, etc., into their data lakehouses, data warehouses, whatnot. And why CI/CD is important for us at Airbyte is because part of Airbyte's draw is that there are a lot of different connectors, as we call them, a Stripe connector, a Google Ads connector. And for each one of these, we build and test and deploy these as containers. And so the more that we have, the heavier of a load on CI/CD that we have to contextualize. So I became quite interested in this problem whenever I came to Airbyte because at the beginning it seemed almost intractable. There were a lot of different moving gears, and it seemed like there was just no way that we could get a handle on it. So I want to tell you the story of how we managed to segment out this problem in such a way that we feel that we can scale our connector situation and building our platform at Airbyte as well. All right, so we'll start by going through what YAML looks like at the very beginning of a company, or just in general of a software project, and how it kind of can evolve over time into this day 101 scenario. And then what we'll do is we'll break down some abstract concepts of CI/CD, maybe not some perfect abstractions, but just some ways to get us thinking about the CI/CD problem and how to think about how to design these systems that may not involve YAML. Then we'll go into what this actually looks like in code. And then lastly, we'll go over the takeaways of what we found. All right, so as you may have guessed, Airbyte was Bart. We had 7,000 lines of YAML across 2 repositories. We have a kind of a quasi-mono repo set up at Airbyte. It was a rat's nest of intestable shell scripts. So for those of you who are familiar with these systems, you may understand, yeah, it's pretty easy to just inline a shell, whether it be Jenkins, where you can just paste it into the window, or you can just throw it into your YAML, or you can call it from YAML, as we'll see. There was a lot of subjective developer pain. We'd have a lot of people coming and complaining that our CI/CD was not great, it was not fun to use, it slowed everything down, and it was expensive. Now, $5,000 a month may not be a lot for a lot of people in different organizations, but for us at the size of our organization, when we first approached this problem, which was about 40 to 50 engineers strong, it was a large bill. And so that gave us some motivation to really take a look and take stride at this problem, right? And then 45-minute wall clock time, again, for some organizations, maybe this is not a lot. You know, I think infamously it took 5 hours or something to build Chrome at one point. But for us, being part of this fast feedback loop was important for us to be able to ship and iterate quickly. So we looked at this as one thing that we wanted to look at improving. All right, so let's jump into day one versus day 101. So this is sort of how YAML can start off great and easy and kind of get out of control after a little while. So you start off with a really simple workflow, right? You just got one thing and it's one file and it's doing one thing. And it works great, right? Like you built it and you were able to get it up and running really quickly, and it's simple and straightforward. It's YAML, it's easy to read, right? There's no indirection or anything. But by day 101, because of the way that we've built out these actions and these workflows, I'm using GitHub Actions terminology here, but it's applicable for other systems as well, where you can use YAML to call other YAML. Suddenly you've got a stack, right? You've got a call stack in YAML and you don't have jump to definition, right? And it's difficult to work as a software engineer when you don't have jump to definition, right? Like you're afforded only the rudimentary tools of browser windows and jumping back and forth in file names, and it's just a cumbersome experience. So this is another example of GitHub Actions. Again, it's got these units of code that are pretty great for certain things. This is one we use at Airbyte. It's on the left. You'll see test reporter. And what this does is it parses JUnit files and uploads them somewhere. It's a great piece of code, right? The problem with this is that there's a lot of complexity in this GitHub action, right? There's like probably maybe 4,000 or 5,000 lines of Python in just this GitHub action, parsing the different coverage reports and stuff. So when you have a problem, you have to, that's within the action, you have to kind of jump into the action itself, right? And so you've got to kind of get this black box. And again, when there's only one, there's no problem, right? But when it gets to day 101 and you have several hundred of these, suddenly you've got a system where you don't really know all these third-party integrations that are around, and the tooling is not there to really tell you. And there's just a bunch of black boxes of things that can just break for no reason. One very typical scenario we end up with at Airbyte is like some breaking change gets pushed to one of these actions and it's not pinned properly, and you don't really have the tools or mechanisms to find it out except after the fact. Your CI/CD is just broken, right? Another example, so on the left here on day one, we've got a very straightforward thing that is very realistic. This is what your first Node app build might look like, right? And again, it's easy to grok what's going on here. We're just installing some dependencies, we're running some tests, we're building a production version of this app, we're deploying it to stage, we're deploying it to prod. Very easy, very straightforward to understand. But by day 101, when you're doing a bunch of these, right? In this example here, we've got 20 or 20 plus. It's really kind of hard to understand. Again, you can't really isolate these things. You can't really test whether deploy to staging is working with these YAML scenarios, right? And we don't even know if what we're going to change, what's going to run anymore. So if you touch a single file in your repo, let's just say it's a single JavaScript file somewhere, how many of these on the right are even going to run, and where and why, right? The tooling to surface this information for you is not there yet. One final example here. So we have some simple Boolean logic examples on the left here. This is a very simple example where we just check and see if a JavaScript file was modified, and then we run the CI. And on the right, we've got some actual Airbyte code that ran for a long time to figure out whether or not we should run the deployment. So you can kind of see here what we're trying to do is we're trying to express some kind of complicated Boolean logic concepts in YAML, and we end up kind of being limited by the constructs of what this DSL is offering us. It can get very complicated and very hard to understand. Okay, so kind of pulling some of these ideas together is like, why is this becoming painful? And in general, we have a lack of modularity. We don't have an easy way to isolate these components. We're kind of limited to what YAML is doing, and we're kind of limited to what the specific DSL is doing. They're not unit testable, so we don't really have a way of detecting regressions before we throw them up there. All we can do is run them against this remote system. We have some ecosystem-related flaws. Everybody has their own kind of quasi-DSL. So if I take GitHub Actions code and I want to run it in CircleCI, I can't just do that. I have to port it, and maybe some concepts don't exist in CircleCI. Maybe some concepts don't exist in GitLab. It's not portable, and it's kind of intractable, and it's this kind of proprietary system where you don't really see all of the source code of what's going on, and there's these settings and configuration that are kind of magical that come in. It's hard to emulate locally. And the point I'll make here that I think it's key when we start thinking about CI/CD systems is you want to be able to iterate quickly. And this ripples out in so many different ways. So if you want, I'm working kind of in a platform engineering role right now, and I want the developers I'm working for to adopt tooling, to be excited about working on tooling. And when they can't work with the tools that they have locally, it's a very bad developer experience for them. So there is a tool out for GitHub Actions specifically that gets brought up about this. It's called Act. And Act, it works. It's better than nothing. It has some limitations, and those limitations kind of, they segue back into the fact that it's a proprietary system that it's trying to emulate. So A, it's always going to be behind the pushes, and B, there are just some things that just don't translate very well when you're running things locally. Okay, so with that said, we've talked enough about pain points. Let's kind of break down what CI/CD is and some, maybe not perfect abstractions, but just some high-level system layers to think about is like, what is this YAML actually doing? We have this giant pile of YAML we've talked about. What is it actually doing? So we've chosen to kind of break this out into what I'm calling layers here. And these are the 6 different roles, if you will, that a system like GitHub Actions or a system like GitLab or a system like Circle is providing for you with all this YAML. So, and it kind of goes back to what Justin was saying about the complexity of CI/CD. There's a lot of stuff buried in here, right? So when somebody talks about GitHub Actions, they could be talking about any one of these things. They could be talking about all of these things or a subsection of these things. So it's pulling these out into some sort of layer helps us to make this into a more tractable problem instead of just being able to say, okay, it's complicated. So let's dive in. What are we calling an event trigger? This is how CI jobs responds. So we're just responding to an event somewhere. Your CI job has to run somehow. So this is pushing to main. This is commenting on a pull request. This is creating a pull request. This is the thing that tells your CI/CD system to do something. So you can also think of this as the entry point to your application. So every CI/CD has this, and one thing I want to call out, and we'll come back to later, is that this is going to be very CI/CD platform specific. And what I mean by that is what GitHub calls an issue is not the same thing as what GitLab calls an issue, is not the same thing as what Jenkins calls their level of abstraction. There are all these terms, and there's no cohesive model where you can say, okay, a GitHub issue translates to a GitLab issue. Some of these concepts, they exist and mostly map to each other, like a pull request and a merge request, but not all of them. And then in the bottom here, I've added like a kind of a rough estimate of how hard this was for us when we tackled these parts, these layers at Airbyte. So I added this 5% number here. This is an arbitrary number. It just wants to, I want to use it to highlight kind of like where we put the most effort and struggle into as we were kind of figuring out the lay of the land on this. So we put 5% here. Okay, authentication. So you need to talk to remote systems in a CI/CD. You often need some sort of secret injection. You're usually logging in somewhere. You might be doing a deployment. You might be uploading to some bucket. You might be doing some logging. Your system needs to know about this. And this is important because if we're going to design something that's perhaps a little bit more locally faced, we need to have that in our mind when we think about secrets, how they're going to be handled on the local developer's machine, how we're going to do secret stores, and the like. The orchestrator. This is a big part. This is where we tell the executor, which we'll talk about here in a second, what to run and where. So some examples are, I want to run some job on a machine, and this is what jobs and steps are in GitHub Actions. And this is also state management. So you have the state passed, you have the state completed, you have the state failed, you have the state skipped, and then you have perhaps, it's usually easy to think about this as a DAG. Some sort of workflow orchestration is happening in your CI/CD where you've broken out things into steps, into jobs, and then you're doing things based on the results. So a very, very simple example here, again, GitHub Actions, is we've got build job 1, we've got build job 2, and then we have a test job that depends on build job 1 and build job 2 succeeding. So we've got both parallelization and state management in this example. Caching. This is typically tied to your execution layer. I'm saving nearly the best for last. It's hard. I think that most people in here that are engineers can resonate with that. It's very difficult to get right, and it's important that you choose the right tooling and the right approach to do this. I don't want to go deep into caching right now, just because I think it's a topic that warrants a talk all by itself. But there are two broad categories that you deal with in CI/CD. One is called the build cache, and that is when, if you say that in a good CI/CD system, you want your system to be able to act the same way if you run it over and over and over again with the same inputs. Idempotent is the fancy term for this. If your CI system works like that, and you know what's going in, and you know the output already because you built it an hour ago or a week ago, then you don't even have to build it. That's the concept of the build cache. And then the second part of this is the dependency cache. And this is like your typical package manager, NPM, PyPy, Maven, whatnot. This is just the concept of, oh, we're going to be downloading from PyPy over and over and over again. Why don't we move the dependencies either on the same machine so that we're not re-downloading them, or close by, AKA in the same data center, so that we can shuffle things into there quicker and not rely on a third-party system. So this is about 10% overall. Like, again, I said this is a topic all by itself, but when you think about it overall, for us, it was about 10% of the overall complexity. Okay, the executor. This is the meat of your CI/CD. This is actually running your build, test, or deploy. So this is what it looks like, a very, very simple example in GitHub Actions or Circle. You're just executing a shell script here, and that shell script may be doing any arbitrary amount of thing. This is a great example because it actually highlights how you can hide very important logic away in a shell script, and you don't really have a good way of jumping into it. So there's a couple other examples, is that you might run a containerized build with BuildKit. That's another way to run things. You can delegate to an entirely different task executor via command line call, like Gradle. For those of you who are in the JVM world, you're probably familiar with this tool. But this is a very large part of your CI/CD system. And we'll go into what we want to think about with this a little bit later in the presentation. Okay. Lastly is reusable modules. It's kind of, I put this in a layer by itself because it's kind of the knot that ties the other ones together, if you will. It's the aspect of reusability that you need because everybody is going to do common things, and why are we doing the same work as somebody else doing a common thing? So for instance, an example I gave on here is that everybody needs to upload to an S3 bucket probably. So we have an action that you can just go grab off the marketplace, and it's great. You can just upload, and you don't have to maintain your own code, right? Some other examples, so this is the GitHub Actions marketplace, but Jenkins has this concept of plugins, which isn't exactly like the marketplace, but it's a similar concept, and then GitLab has some integrations as well that offer this. And this is about 10% of the overall complexity of what to think about. Okay, so we managed to break it down, and we've picked some terms, and we put things into some boxes so that we can kind of think about CI/CD as something that we can put in some layers. Okay, so now we're going to talk about the Lisa approach. So what is the Lisa approach? The Lisa approach is to think about CI/CD as something that is not something that we don't want to use YAML for, something that solves these problems of scalability, something that is actually fun to work on, something that, and I'll use this term, you don't have to push and pray. So anybody who's worked on GitHub Actions or Circle or Jenkins knows this feedback loop where you're pushing to a pull request, commit by commit, over and over just to get this one little CI/CD thing to pass, right? It's just like now you've got 30, 40, 50 commits and they're all little one-line changes in your YAML file, right? Nobody wants that, right? So what if we had a world without that? How would we even go about doing it? All right, so the first thing to think about here, kind of tying it back to what we were talking about before, is that we want to think about local first. And it comes back to the reasons that we mentioned before, right? It's that developers want it more. We get faster feedback loops if we're not having to do the push and pray, right? As we mentioned earlier, it got pretty pricey for Airbyte to be doing CI/CD over and over again. And so if we can do those feedback loops locally on a developer's machine, it's much cheaper than renting machines from the cloud to do it. We get better debugging. We can actually have step-through code, which to me is like a fundamental tool that every developer needs to have a proper development environment. If they cannot step through code, then in my opinion, you don't really have a development environment. And then you get better modularity, right? You get to extend things and work on things, and going back to our key tool earlier, jump to definition. All right, so one of the key design aspects that I wanted to call out that we sort of learned when we were thinking about this at Airbyte is that you need to start from the bottom layer when you think about if you're going to design a CI/CD system. And the reason for that is because the caching, the execution layer, they're so critical to the core functionality of what your CI/CD is doing that everything else at layer by layer on up needs to be informed by that. And just to give you some examples, I mentioned Gradle earlier. If you were going to build your reusable CI/CD system that was modular on Gradle, you would have to make certain design decisions about the runner infrastructure that you were going to run on, the reusable modules, are you going to use Gradle plugins? All of that stuff is kind of informed by this bottom layer. And that answer is going to be different than if you use, like what we did, is building it on BuildKit, right? So there are different design decisions, different concerns, and they're all kind of informed by whether or not you use Gradle, Bazel, or BuildKit are the three that we're going to talk about today. And the last kind of key point that I want to make here is that this concept of event triggers of like something is running your CI/CD, those, as I mentioned earlier, they're very platform specific. Again, Jenkins doesn't have the same way of running things and same terminology and same data model as GitLab does and as GitHub Actions does. But the rest of the system doesn't have to be. So we're going to introduce a way to box up our layers, right? And this is going to be a simple way of thinking about it. And the idea here is just wrap them up in a CLI. Why? Because CLIs, developers like them. They're developer friendly. They know how to use them. They can be created relatively easy. There's a lot of good CLI libraries out there already. And they're also good for a machine to understand. So I'll demonstrate in a bit here that you can design a CI/CD system that basically just clears its throat and says, go CLI. And that is the beauty of being able to wrap it up in something that a machine easily understands that's also configurable. So this kind of design approach tries to ride the balance between these. How can we make it machine understandable and configurable, but also still happy and available for developers? So we'll start from the bottom up, and we'll talk about some of the design decisions we made in the Lisa story here at Airbyte. So when we went through this design decision, we came from a Gradle land. A lot of Airbyte is built on the Java platform, and Gradle is a very powerful execution tool, but it didn't work very well for us. I think that's a topic for another talk. We chose to use Dagger instead. So what is Dagger? So Dagger is a way for you to run execution in containers. It is an SDK on top of BuildKit. It's a way for you to define your execution layer entirely as code. And one of the more interesting design decisions here is because it's backed by BuildKit, it has an opt-out caching approach. And so from a DX perspective, caching, going back to what we were saying before, it's a hard problem, right? There's a lot of different things that you have to do caching right. And we feel that giving developers caching by default is the right way. And one of the interesting things to point out here is that when you think about your execution layer and you think about your caching layer, they must fundamentally go together. And that one of the limitations of GitHub Actions is that it's not. Caching is something you bring in entirely separate, and it's something that's opt-in, if you will. And so choosing a tool, whether it be Dagger or BuildKit or Bazel or Gradle, needs to have this caching aspect baked into the very core of what it is for it to be successful. So again, caching, we leverage BuildKit under Dagger. There are a few other mature options. I mentioned them already, Gradle and Bazel. They each have their pros and cons, and I won't go too deeply into them, aside to mention that Gradle eventually ended up not working for us because it was too complicated for our developers to understand. So let's talk a little bit about orchestration. So orchestration, the Lisa way, going back to what orchestration is, this is an arbitrary term that we put on. It can be a general purpose language construct in your design, or it can also be a specific tool chain. And so at Airbyte, we came from a very data transfer, data heavy specific background, so we chose Prefect for this. But this could also just be your typical asynchronous programming language construct in your language of choice, whether it be Golang, whether it be Python, whether it be JavaScript. There are other tools out there. Gradle and Bazel have this aspect built into their platforms. There's also Airflow, which people have probably heard of, is a workflow orchestration tool, and a couple others, Dagster and Temporal. Just a few examples of how you can get some visualization and things like that from your workflow orchestration tool are below. And lastly, the event triggers. So these don't change. So because these are the very, very CI-specific part, this is the part of the data model that is very, very Jenkins-specific, very GitLab-specific, et cetera. We push anything that's specific to that model up into that layer, and it becomes a very, very thin layer. And then running locally is just executing another event, if you will. By doing this, we can actually mock the remote CI locally by mocking the GitHub Actions, in our case, events, by doing this. Lastly, remote modules. So these are just code modules. So this gives us all the things that we wanted before in the BART approach. Jumping to definition, unit testable, no more black boxes. We can use our language constructs that are probably a bit better and a little bit more robust than GitHub Actions distribution for our packaging. So instead, maybe I want to use Rust crates to do distribution. You can actually implement a shim for migration. So one thing I'll bring up here is maybe you want to move to a system like this incrementally, right? So you can implement a shim that will invoke GitHub Actions, marketplace actions locally. The Dagger team is also working on a solution for this. I'm excited to see what they have to offer. But any sort of code construct that you need to make for your end users, and one of the points that I want to kind of drive home here is that the important thing when you're thinking about CI/CD is that your end users need to want to be and very comfortable with using it. And so being able to work with the language of their choice, so the front-end people at Airbyte want to work in TypeScript because that's what they're familiar with. So thinking about a solution that is comfortable for your end users is going to give you a lot more power, and you're going to see a lot more uptake when designing a CI/CD system for others. All right, so enough talk. Show me the code. Let's do a quick demo. So what I'll do is I'll show a couple quick runs of the CLI system, and we will also do a quick step through of the code just to kind of see what this actually looks like when you start to abstract some of these ideas out. And this isn't maybe the only canonical way to approach this, but it is a way, right? Okay, so we've got a CLI tool that I built over at Airbyte. It's called AirCMD. And this is just a click Python wrapper, and it just has some very simple commands. It builds itself and it runs its own CI. So what we're going to do is we're just going to run a quick command to run CI. And an interesting thing here is when we do this, one thing we can do from a UX perspective is to make these commands composable. And what I mean by composable is, and we'll look at this in the code, is that there's actually three things happening here: build, test, and CI. And so the CI does some things, but it calls test. And the test does some things, but it calls build. And so your end users can kind of get little stages of progress as they run. If they only care about the build stage, they only have to run the build stage. They don't have to wait for anything else. Okay, so you can see here that a lot of stuff was cached, and what you're seeing here is actually build kit commands. And we can actually go look at the run. This is the Dagger Cloud here. And we can see it here. And you can kind of see this is one of the DX things that I think is incredibly important to highlight when it comes to caching, because caching is so difficult. Being able to see what's cached and what's not easily is pretty key to having your end users be able to write performant code. And here you can see that most of this, almost all of this run was cached. So it took almost no time at all. And then what we can do is we can actually bust the cache. So we're going to go take a quick peek at the code over here. And we're going to take a quick look at the code, and we'll start. Let's go ahead and start at ci.yaml. So this is the event triggers layer that we were talking about earlier. There's some minimal stuff in here, but the idea here is that you have some CI/CD specific layer, but all it's doing is essentially calling CI. And you can see here that that's what we're doing. We're setting some environment variables, we're clearing our throat, and we're running the CLI. And then once we do that, we get into the orchestration layer. I left auth out of this demo for purposes of brevity, but you can think of auth as just being a module in this setup. In our orchestration layer, we've defined 3 commands. And those 3 commands, they're being submitted asynchronously, and they're calling each other. And this is just regular Python. We're leveraging some prefect constructs, but under the hood, it's just regular Python. And then we jump into the execution/caching layer. And then what's happening here is kind of interesting. Essentially what we're doing is we're loading, you guys know of them as Docker containers, but OCI compatible client containers. We're loading those, and we're just running commands inside of a container. And now we get unit testability, we get the ability to specify cache layers. And one easy way to think about what's going on here is each one of these commands it's not perfect, but it's roughly analogous to a Dockerfile run command when it's happening under the hood. So you could kind of replicate this with buildx and Docker as well. So it's a not quite one-to-one, but pretty close. And then, so what are we going to do? We're going to do something that busts the cache. So what's happening is we're taking files, we're loading them into a container. And so if I just make a change, we'll just add a white space, maybe a comment. It's going to change the inputs to the container. Now remember, we go back into what was happening before. We talked about caching. If the inputs change, we're not cached anymore. So we're going to rerun the same command after we've added our comment, and we're going to see that it's not cached. And it's going to actually do some work here instead of skipping everything. And so now we'll take a quick look at the visualization tool here. Take it a quick second. So these are hosted in the cloud. They can be local, but they're hosted in the cloud. And what's happening is the client is actually streaming this data to them in real time. So we can actually see the job running in real time as we go along. You can see we've already gotten pretty far in this one, and it's running the pip install. So that's the core facet of the demo here, is that we want to demonstrate that we have some tools to visualize what's going on, and we want to give our end users the ability to peek into the core facet of our CI/CD system, which is the cache layer here. And again, once we're in, we can just jump through all of our code, right? So if we want to see what these commands are doing, we just go to definition, we get our jump to, and we have a stronger DevX than we did with just pure YAML. And we can walk all the way down the stack to the build kit base. And okay, so I'm going to jump back to the presentation here. We're going to slideshow again. All right. key takeaways. So let's talk about Lisa's light at the end of the tunnel. What does this actually mean for Airbyte? We spent some time and we refactored some stuff. What results were we able to show? How were we able to improve things for our end users? So one thing we were able to easily do, this is the output of the tool clock, count lines of code. We were able to, over the course of 3 months, we're still incrementally working towards it, we were able to reduce the amount of YAML by 50%. What we did is we worked towards this incrementally. We picked the nastiest, most painful builds first. We wrote up a proof of concept that was a very thin framework that handled those nasty, painful builds, and then we incrementally started bringing things over. We added unit tests every step of the way. One of the key performance indicators that we wanted to make sure was count the regressions. How hard is it to make a pipeline that doesn't regress? We were able to achieve 90% cost savings. And part of this isn't really indicative of the tooling that we chose, but more that we were able to leverage the tooling that we chose and the system that we made to be able to really easily go in. Going back to looking at the caching GUI from earlier, we were able to really easily point in and go identify bottlenecks for where caching was being really painful. So to kind of like describe exactly what this meant is for instance, we were trying to test 70 connectors, which is just a container output that gets tested every single day. And in the previous time, in the BART times, we were spawning one machine in parallel in GitHub Actions for each one of those connectors, which was a very expensive endeavor. After we did this, we were able to leverage caching such that the layers were all shared within each other, and we switched to a single machine approach. And in the time it took all 70 connectors to run wall clock, we were able to get that same time on one machine. So that was a 70-time reduction in machine time. So that's how we were able to achieve such massive cost savings. We're able to test connectors more often, and our developers are much happier because they have an environment where they can actually debug problems, and we've gotten away from push and pray, which for us was a major DX win. So kind of pulling it all together, YAML is a great tool. It works really, really well when you're doing something simple. So in some cases, it's going to be enough. If all you're doing is maybe you've got like a side project, or what you're doing is never going to be very, very complex, maybe YAML is the answer. But when you start to scale, when you start to grow beyond a certain point, it really starts to fall apart. And for us, it happened right at about the time that our system became complex enough. Day 101 was probably at year 1.5 for us. So it did take a while for us to really sit back and acknowledge it, but it's key to recognize when you're starting to get into that area of when it's going to be a little crazy. As mentioned before, we saw some major reduction of machine days and just had some huge cost savings wins, huge performance wins. And when you think about this again, think about it from the ground up. Think about it from the execution and caching layer first, because and again, this is a whole other topic, right? How you actually run these things on a remote system has a lot of nuances and caveats as well. It's like, okay, I have a cache. How do I get it onto the machine where it's running in a fast and easy way? Build the tooling and constructs your developers know. This goes back to the Airbyte front-end people want to run in TypeScript. So giving people an environment they're comfortable with is going to give you adoption and mind share and power for your developers to feel empowered and feel like they want to work on the system instead of it being something like Justin mentioned earlier that just gets kind of pushed to the wayside in a lot of organizations. Incremental migration is possible. So the idea here is that when you take this whole thing, this whole blob, it seems a little intimidating. There's a lot of moving gears in a CI/CD system. So it is possible to build a bare bones thing. What we did is we built a bare bones system, and then we ran in parallel the same job for a week or two, and then we switched. And the last thing is get away from push and pray, right? We want to be able to do this locally. Thanks everybody for your time, and that's my presentation, and open the floor for questions.
I feel like this, like you kind of alluded to this earlier in your talk, but like this tends to be like a slippery slope, right? It's like you start out with one YAML file, and then there's like some point on the curve down to the 101st day where things have like gone too far, right? But at that point, it just always feels like such a lift. You know what I mean? To like go, it's like, okay, that's it. Stop this madness. like that kind of stuff. And so you end up just piling on. Like, organizationally, personally, like, how do you solve that problem? Like, how do you get it buy-in for like saying, okay, this is madness, this needs to stop? Like, how do you do that piece of it?
Yeah, so this was definitely something that came up at Airbyte as well, right? And the key methodology for success in our case was to demonstrate the win. And so, especially in this area, there's not a whole lot of, there's a lot of, I don't want to use the term stagnation, but there's a lot of like, this is the way that people do CI/CD, right? So when you're coming to the table with a new approach, you need to be able to demonstrate a very dramatic win like we were able to do. And so finding the right proof of concept is pretty key. For us, it was finding the nastiest, slowest, flakiest CI/CD job and saying, okay, let's just take a week and a half and spike out what this can look like. And just getting something out there that's bare bones that shows some very, very dramatic wins, I think is the key political way to sort of help drive adoption and get people to see the possibility of what you can do.
Thanks, a great talk. Lots of thinking points there. Was there anyone who actually pushed back and said, "Hey, I like YAML"?
I think that some people do appreciate the simplicity of it, and there are some benefits to being able to have something that's standardized and quick and easy to grok. Contextually, once you get to a point in the organization where you're doing, in some of our most egregious examples, there were inlining Python code in the YAML, and it was very easy to see for people in our organization how it had kind of gotten out of control, and maybe other organizations haven't gotten to that point yet, but when it is bad, it's very obvious that it's bad.
Has the kind of developer experience of not having to, kind of re-push and iterate on CI, has that kind of changed the developers thinking about how CI should be?
Yeah, in our organization, there's been a larger adoption, just a big push in general towards local first tooling, and this is part of that story. And what we're seeing in our organization is that there are some organizations I've worked in the past where, kind of alluding to what you were saying earlier, Justin, like it kind of gets shoved over to the DevOps team, the build does, right? And so what we're seeing in our organization is that more and more people are becoming more actively involved in wanting to work on these systems and contribute to them. And really was kind of our pie in the sky goal from the get-go, was to sort of bridge these gaps between different organizations and not just have the DevOps guys who do the pipeline, that everybody kind of works on the pipeline together. We're all engineers, and we all work on the platform together.
It works in marketing, yeah. So I don't have a question, but I think one thing I would like to add is the portability of your solution that you're using, because we are having GitLab and Azure DevOps in a company, 1,000 people on one, 1,000 people on the other, and try to have them to migrate to one platform, because we have two teams maintaining the stuff and running the stuff, and putting this into a, you could say, CI/CD tool independent approach. You can then easily move from Azure DevOps to GitLab or GitHub, etc. And that's, I think, also a very strong selling point for this.
Yeah, I didn't touch on that too much in the presentation, but that was something that when we looked at different ways to approach this, we looked at some other platforms and stuff like Earthly and the like. Being able to take a step back and not be married to one specific platform was a big selling factor for us.
No, I agree, because the cost of moving to one YAML definition to the other lost work for the teams, and it's very painful. And this might be the way out of this. And it's the current marketplace with this sort of tooling is still very volatile. So where I don't know, you had Jenkins or some predecessors were then popular. Every 2 to 3 years you see different tool here. So it's really imperative to have something vendor independent in place.
Yeah. Cool.
What do you see as your sort of next steps? Now you've got here. Where are the pains you still have? What's the roadmap forward?
Yes. So that's an interesting question because where's the long tail in this, right? No solution is perfect. And so where we have hit the long tail that we're hoping that there can be some improvement is, especially if you work in a microservices-like setup. I think this is just an unsolved problem in kind of DevOps, CI/CD systems in general, is if you want to have these reusable modules, whether they be your own because you'll need to make your own, or whether they're maintained by somebody else, how do you manage the distribution of all these modules, right? Let's take a typical microservices example like Bart's example. He's got 30 different services, right? How do we manage this tool and the versions of this tool and all the packages and all the plugins and all of that, and be able to deploy updates and test those updates and do that in a robust manner? So that's kind of like the longer tail challenge of what we're still kind of like coming up against, and trying to tackle that has been one of our priorities, because a lot of work is kind of on the platform engineers to kind of maintain that ecosystem. And so being able to solve that problem would take a pretty big load off of the platform engineering orgs.
Final bonus one. Is there any disadvantages to using Dagger? Because I've definitely seen analogies here with like YAML and Kubernetes, something like Pulumi, and like there's always advantages for code versus declarative information, right? And I'm super interested about Dagger, but I haven't played with it much yet. And I wonder, is there any kind of foot guns I should be aware of, or any challenges?
Well, part of it is that it's a very new technology. So it has all the caveats that come with new technology. I think the one thing when it comes to Dagger and in general just build kit that we've run into challenge-wise is it's a new concept for a lot of people. Being able to, and build kit itself is relatively new technology as well. And so getting people to think about things the container way may be a challenge for some organizations that are unfamiliar with it. For us, coming from Gradle, it felt like less of a lift, because Gradle is, for us, it was almost interminable at sometimes. So that was, I think, the two primary challenges that we had with Dagger were that it's kind of new technology. It has all the facets of that come with it, and containerized builds like this are just new technology in general, and people aren't as familiar with them.